Okay, so good morning. So now is morning session. I try to continue my this discussion part. Okay, so now we start with this session B. Okay, so this form two mathematics. Form two mathematics session B part. So session B we have a total of 20 marks. So let's see one by one. Okay, for question one is about this geometry. Okay, so let's see this one. Given the polygons, okay, we have hexagon, and there are how many gone here? How many edges here? We have 8 vertex here, right? 8 vertices. So this is a octagon, and this six has 6 vertices. So we name as hexagon. Okay, so doesn't mean that this regular. Okay, so we just present in regular hexagon, but in general it's hexagon. Okay, so they ask you, okay, to find the number of triangles and the sum of interior angles. So actually this one, okay, they ask you to find these two information. That means these two information actually they have some relationship. Have some relation between them. Okay, 有关系的. Okay, so that means we try to find out why we need to find the number triangle before we find the sum of interior angle. Okay, so because we know that in previous, or when you try to learn this we will try to find out the sum of interior angle for one polygon. Okay, we understand that we can try to relate how many number of triangle we found in the polygons. So let's say we need to find the hexagon, the number of triangles in hexagon. So we can try to use one vertex. Okay, let's say we start from this vertex. Okay, can you find out this vertex first? Okay, and we just line, okay, connect this vertex to another vertex, form a diagonal. So let's say we want to here form a here diagonals here to here, form a diagonals to here, form a diagonals to here. Okay, so the another two diagonals of here to here you cannot form because you already form an edge. Okay, so no need to draw again. So we have how many triangle we have? So we have 1, 2, 3, and 4. Total we have 4 triangle in this hexagon. Okay, so if you try to relate number triangle with the sum of interior angle, because one triangle we have 180 the sum of interior angle, okay, inside the triangle. That means if I want to find the hexagon, we need to use a 4 times 180. So total we have 720 degree. Okay, please remind you please write the degree sign. Okay, degree important because this is ask you for to find the interior angle, the angle. Okay, not just write down 720 only. This is not the value. Okay, it is the size of angle. Size of angle and the value of size of angle, this must have a sign, this symbol. Okay, symbol of degree sign. Okay, so the next one for the octagon. The octagons are, so we same with the previous one. Okay, we try to start from one vertex. Let's say I use this the inside one. Okay, so we try to connect to another side or another vertex. Okay, 1, 2, 3, 4, and 5. Okay, so how many triangle we have? 1, 2, 3, 4, 5, 6. Okay, should be like that. We are not to connect using this method. Okay, some student they try to connect like that. They try to find a point in center, any point inside the octagon. They try to draw this one. Okay, like that. Okay, it's not okay. Although we know we can find a number of triangle inside, or we after we divide, we form the 8 triangle. But for the sum of interior angles, we will confuse also, because here total we have 8, and we need to find out the total in the sum interior here. And then here we count already, so we need to minus 360 degree. So very complicated. So that's why we are not recommended, okay, you to try to use this one. So you form a diagonals here. It's a better way. Okay, so a number triangle we try to delete like that. So form the diagonals, divide the diagonals lah. Divide this polygon, okay, into triangle using the diagonals. Okay, so we have 1 2 3 4 5 6. Okay, so 6 triangle we have. So we use 6 times 180, so total we have 1080 degree. So this for question 1. So I hope that after you understand this one, if you try to find the sum of interior angles, so for this and any polygons, so you able to find out number of triangle. Use the relationship between these to find this one. Okay, so this is question 1. Okay, now for question 2, fill in the blanks with the suitable answer. So this one, okay, we must have the correct mathematical terms or the names, okay, based on that we learn in the property of circle. So these 4 questions actually it tests your the knowledge of the basic concept for the properties of circle. So let's see. Major sector is a region in the circle that is enclosed by an and what? So it's give you a clue only already. And what? So any mathematical terms or the names of the parts of a circle is consists of the vowel a, e, i, o, u. So we know we have angle, no angle, we have arc, right? So in this circle, I need to draw a circle lah. Better we draw a circle. Okay lah. Okay, we draw a circle. So let's say we draw a circle, but this circle not too big. Maybe I give another empty one. Yeah. Actually, I need to do this one. Partition. Okay. This partition very nice. Okay, so for left hand side, I try to draw a circle. Okay, so it's a circle. And with this question. So major sector. So let's see the major sector. Where is the major sector? So let's say we try to draw a major sector. I want to have a major sector. One here, another one here. So the major sector is here. Okay. So that is enclosed by and what? And what is arc, right? ARC or arcs. And two what? Two what? An arc here already have another two. This one what we call this one is one radius, another radius, right? So actually for the plural of radius, they have more than one radius, we call radii. This one we call radii. Radius, I'll change to radii, not radiuses. I'll keep the radius the name. Okay, so this one is radii with the angle subtended at the center is more than 180. Okay, so we have this condition. The first condition is if you want to build a major sector, or we want to consider as a major sector, the first is we need to have an arc and two radii. Okay, form, and then they are enclosed area. Okay, in enclosed area, and then the angle between radius, right, inside this area must be greater than 180. So that's why this major sector can be formed the region. Okay, so the question part 2. Okay, now we try to part 2. Okay, the what is a longer straight line? Now you see what is a longer straight line that join any 2 points on the circumference and passing through the what? Okay, so we see this one. straight line that join any 2 points on the circumference. Do you know what is circumference? So circumference is this one. Just like perimeter lah, but it's the length around the circle. This one we call circumference. Circumference. Okay, so any 2 points we point on the circumference, where can which one or which drawing or which construction we can make a longer straight line. So here, is it here? No, right. Actually, we need to pass through this one. Make a half. Pass through this one. What is it we call? This one is the center. Pass the center. And this one, what's the name for this line? We have two radii. Connected by two radii. Parallelly, because this line and this line are parallel, right? They are in same direction. So what we call this one? This one, the straight line, we call as diameter. Okay, so this one, the diameter is a longer straight line that join any 2 points on the circumference and passing through the center. So this one is center. Okay, so the third one, what is a straight line that join any 2 points on the circumference? Similar with the question 2, straight line that join any 2 points circumference and full stop. So now it's full stop already. That means it can any 2 points. Just now I redraw any 2 points here. This one any 2 points. This one what we call? What we call this one? This line. This one we call as chord, right? Chords. Okay. So if you want draw right now, you maybe can write down a chord also can, or just write down chord also acceptable. Okay, chord. Okay, it's a straight line that join any 2 points on circumference. The longest chord. Just now we learned already, right? The longest chord, it must be in this position. Longest chord. This one we call it's a diameter of the circle. Okay. Yeah. So last one. Which part is an area bordered by and what and a chord? Which part is an area? Okay, let's say we want to find the area, border and what and a chord. Just now we learned about a chord, right? A chord. Okay, not chord is not the 法庭 the chord, okay. Okay, so this is a chord. Okay, so a chord we learn this one. So if we try to relate this one, a chord with and what? Just now the first question we learned about an arc, right? So an arc is here. Okay, maybe it's here, or it's as long as if I try to connect this one, I cannot. I need to use a color, different color to let me see. Okay, let's say I use green color for right hand side. So on right hand side here is a major segment. If I use the left hand side one, it's a minor segment, right? So both are segment, but I didn't specify which arc we want. So that means we just use segment enough. A segment. I use the highlight a segment. So don't write major segment, minor segment, okay. No specify, don't specify yet. Okay, by an arc and a chord. So our answer, okay, with this for question 2. Done. Okay, so now we continue with question 3. So circle true or false for the statement below. Or in session C, they always like you to ask this question, true or false, a statement for you. Okay, so you need to identify okay, which statement are true and which statement are false. Okay, so now let's see this question. The first one, a cylinder. This part of question is about the solid geometry or 3D geometry. So we need to understand the properties okay, for the solid geometry. So let's see. A cylinder has two flat face and one curved face. The cylinder. So you must understand what's a cylinder. Cylinder is this one, right? Cylinder. Okay, has two flat face. This one with flat one, another bottom is base. Okay, this one has a flat face and one curved face. This one is a curve, right? So this is correct lah. One flat, one curve and two flat. This is a true statement, so we circle the true. Now, question 2. A cone has one curved face and one vertex. Okay, so we have found that some student, when they see that one vertex in textbook they don't call as vertex they call as a apex, right? If apex, yeah, true, exactly true, right? Because we have cone here. I draw a cone, okay, have one curved face, okay, just curved face, and one apex. This one we call apex, right? Okay, so in textbook we learn apex, but okay, we must know that apex is also a vertical, vertex. Apex is also a vertex, so this one also vertex. Okay, so we will call as vertex also. But this vertex is because the opposite of a base and the higher place, the higher place. So that's why we call as the highest place. We have a dot from this one, the base. Okay, so this is what we call apex. Okay, so for this question or this statement actually is true because a cone has one curved face and one vertex, where the vertex is a apex. So this is a true statement. Okay, so actually when I study so in my PMR level SPM, I just learn vertex. I didn't learn apex. Okay, the word apex that I understand is about the game. You know what, Apex Legend. Okay. So after I try to revise back, okay, see the textbook, I will see this new works Apex, and I try find the definition. This is about a vertex which is opposite to the base, is in the highest place. Okay. Okay, so this apex, okay, means. So the C, a rectangular pyramid has 8 edges and 4 vertices. Okay, so let's draw this one. Okay, the pyramid, rectangular pyramid, they ask for rectangular. So the base must be rectangular. Okay, we have a pyramid. Okay, so it's this one and this one. Okay lah. Yeah, not so strict. You see, don't lah. I write here, I draw here. Okay, so rectangular pyramid have 8 edges. So how many edges we have? So we try to understand it. 1, 2, 3, 4, and the rectangular base I have 4. Total we have 8. Yeah, done. Wow, 4 vertices. This one you need to understand lah. Okay, is it just 4 only? So if I just see, we found that not only 4, we have 1, 2, 3, 4 vertex, and another vertex are here. This vertex is apex. See? So total actually we have 5 vertices here. So, okay, it's 5 vertices, not 4 vertices. And if we try to understand, these 5 vertices doesn't mean that all are apex. There are 1 apex and 4 vertex. Okay. In these 5 vertices, there are 1 apex. So this, because these statements say a rectangular pyramid has 8 edges and 4 vertices only. So actually we have another vertices here, vertex here. It didn't count. So it's a false statement. Okay. So got student come and argue. Hey, because it say 4 vertices based on this one only. didn't say apex mah. Okay, apex is not vertices or apex vertices, but vertices not apex. So let's see in Google. Okay, so if we try to find Google, find Google. Okay, Google. Okay, you search, like this. Okay, uh, you search what? 8 edges. So you say pyramid. Okay, number of vertices. So Google will highlight this one, have 5 vertices. So a rectangular pyramid have 5 faces, is base rectangle or square, and other 4 faces are triangle. So it has 8 edges and 5 vertices. That means these vertices, there are 1 vertices, 1 vertex is included already. So we need to understand lah. Doesn't mean that apex is just apex. So apex is also vertex. Okay. So let's continue. Or D. D. A prism is a solid with 2 opposite faces. So there are some important words of 2 opposite face. They are congruent and parallel to each other. So let's understand what it is. Prism. Okay, prism actually is a solid. Let's say we draw this one, rectangular prism. And then this is a triangular prism. Okay, why we call it as triangular prism? Because we have this base, the base is a triangle, right? Triangle. Okay, and we have two congruent triangle here. One up in the top, at the top, and one at the bottom as a base. Okay, and these 2 opposite face that are congruent or only congruent, they are also parallel. Uh, where because they are parallel also, that means if we try to get the cross section, okay, after we cross section or horizontally or parallel with them, we also can find out, this one is parallel and this one is congruent too, another part here, this one also congruent too. Okay, so this is a prism, that I mean. So it's a true statement. Okay, so what condition if uh let's say I have the base congruent with the top, but they are not parallel. Let's say like this. They try to have a slang a bit, or have a slang a bit. Okay, and then we try to connect. So this one, it will not be the prism, although we have the two congruent faces or two congruent opposite faces, but since they are not parallel to each other, it's not in same line. Let's say it's a horizontal line on horizontal surface, and this one not in horizontal surface. So when they try to cut the cross section in this prism, this this one, the cross section is already not congruent with these two one. Okay, so this one you try to imagine first lah. I don't have the software to present view, so you try to imagine, you understand already. Okay, so these are true statement for opposite faces, they are congruent and parallel to each other. Okay, now we go to question 4. Okay, match the following relation. Now I don't know need this one already. We continue this one. Then determine whether each relation is a function or not. So we try to see the input and output to make a relation first. So 64 can be converted to, let's find out, 2 power of 6, so if we want to use calculator also can, calculator, 2 power, okay, 2 power of 6, okay, I use this Casio EX, is 64. Okay, 64. Okay, so 64 is where the input is 64 here. Okay, so most people they forget this question. They forget this one. Oh, they say this is not equal. It's equal, right? It's input and it's an output. Okay, And then we continue. 8 power 2, 8 power of 2, okay, x square is 64 too. So 64 we connect with x square. That's why we like this. 8 power 2. Okay, so 6 power 2 is 36. I don't need to already. Why they try to draw this? Okay, copy and paste lah. Another one, 5 power 2 is this. Okay, so because some student they might say hey, the output must be in perfect square, so they try to ignore the 2 power 6, but actually 2 power 6 is come from 64 too. So they are equivalent. So 2 power 6 must try to connect to from an input. Okay, so based on these relations, we found that we have one object, one domain, one subject, object. Yeah, this one we call object. Here we call object, and here we call image. Okay, we found that there's one object has two image, more than one image, more than one images. Okay, so because this occur, this is a one to many relation. If one to many relation, okay, as is one to many relation is not a function already, because function we need is every object has one image, every object has only one image, or we cannot more than one image, has only one image. So this is not a function. So the function we need to have these properties of every object, every every object, okay, must have, okay, match with, have one image, one image, one and only one lah. Okay, so this is we have 4 core function. Okay, so this is question 4. Okay, so for this the marking if you wrong, you mistake or you miss out this one, you lost 1 mark. If you didn't draw this one, this two connect this two, also lost 1 mark lah. Let's say I this one 1 mark, this one 1 mark, this one 1 mark. Okay, and then the last one is a function, not a function, 1 mark, total is 4 mark. Okay, so the input and output must try to connect correctly lah. Okay, the last one for this one, diagram 9 show object A B C D E F and image J K L M N O. So we try to identify the image for each of the following cases. So for image for point E, okay, so many student they try to find lah. Okay, so let's see lah. This image is the object, and this image is image lah. What I say. Okay, so this one is object and this one image. So when you see this one, we found that this one can try to rotate. Can you see the rotation? Okay, you rotate. You try to rotate. You try to rotate. Let's say I try to rotate like this. Okay, we have this one. No. How rotate? This one we rotate to shoo another side. See this one rotate to another side. Okay, so we found that the rotation like this. And then we say the first one, point E. Where is the point E? Okay, a point E rotation. After you see rotation, we come we go to the end. If you try to imagine this CD after you rotate with this one. Okay, so we have CD line. CD here is rotate to this one. So this one is LM. Okay, line LM. Before that, we go back to the point E first. E, okay, rotate here to point N. So we have point N. Can I write down N only? So many students they like to just write down N. The question already give point or give the name of point. This is a point. Just write down N. What is this? Is this not the name of a set? Name of set. You learn name of set, you also try to put the N capital letter, right? So we need to specify what is N. So we write down point and point and is better. Follow the question lah. Aiya. So write completely. Write the answer complete in complete way. Okay, so it's point and. So you want just put the and only. Okay, although we know that you just put the point and one capital letter in geometry means that 1 point. I know, we know, but later you know, you make a mistake. So for line EF, line EF here, okay, it's a long side after the E, after the N. So if after the N with the connect with the O, right? It didn't find the N and M, right? So it's N to O. So it's line N O. So some student they write O N. Okay. O N can. Okay. So if you want to specify the image okay, this image okay, for corresponding point with correspond to which point E must be connect with the N, F with O. So it depends so it's N O better. But if you write to O N, because since that this image okay, it doesn't give the direction. So for this scenario, I still accept this ON lah, line ON. Okay, but next time we better write down this one. Okay, after you understand one, because sometimes they very strict the image, okay, must have the points same with another point. If you write down like that E is corresponding to O and F corresponding to N, but actually it's not wrong already. So the direction wrong, arrangement wrong, so your answer will be wrong. So better you write out line O N. No, line N O. Oh, not O N. Right, N O. O N O N O. Where's N O? Okay, N O. Okay, done. So just now line LM also, if anyone you write down ML, I still accept this one, but next time don't write it. Okay, so C to D and D to E, so L to M, M to N, so CD, LM. Okay, the last one is angle. This one, the angle sign. Okay, angle sign. Angle BAF. Where is angle BAF? Angle BAF is here. Okay, it's here. This one. Can you see this one? BAF. This one. I use a highlight. This one. Okay. So where's the angle after you rotate? Rotate. There. So it's here. This one, right? This one angle. This one. Okay. So the angle is here. Here. So how we name the angle? It's better use we follow the arrangement corresponding to which point okay, object with image. So B to C, so L from this one is K so C connect with B, so L connect with K, so we start from K, and then J, and then O, KJO, so it's KJO. Okay, is answer correct or not? If you try to write down like that only, actually it's wrong. It's not present the angle, because KJO in geometry with three capital letter, it means that we can write down this KJO. It's present the line. We mentioned the line only, but we didn't mention the angle. So we need to write down the angle. Angle sign here. So for those who didn't write the angle sign, you lose 1 mark, or you lose 1 mark. Okay. So that's why this important to write down the name. Okay, completely. So there's 4 mark total. Okay, so here we end the section B already. Hope that you can understand. If you don't understand, you price comment and ask okay, so I will try to reply if possible. Mainly I will not to reply after I see I need to reply, explain, I will explain. Okay, so thank you so much.